All right, ladies and gentlemen, I'm going to do the three coordinate geometry problems on test 6. There were two forms. So the first form, I'm going to work with the triangle that has those vertices. The coordinates of A would be negative 9, 5. The coordinates of B would be negative 11, 3. The coordinates of C would be negative 7, 1. If you didn't have this example, you might want to watch this example, and then down the road, your examples will be coming up. This problem requires you to, just given those vertices coordinates, to find the coordinate of the centroid of the triangle. Now, the centroid of triangle is the point of concurrency of the medians of the triangle. And the nice thing about that is that if we were to take the average of the x-coordinates, negative 9 plus negative 7 plus negative 11, divide by 3, and I have minus 27 divided by 3, which is negative 9. And I took the average of the y-coordinates, 5 plus 1 plus 3 divided by 3, I would get 3, because 9 divided by 3 is 3. Negative 9, 3 would be the coordinate of that centroid. In confirming what we've done, we're just thinking of the point of concurrency of the medians. Remember, medians are segments from vertices of triangles to the midpoint of the opposite side. And notice that those three lines intersect in one and only one point, and the point's coordinates would be negative 9, 3. So that's example 1, or problem 1. Now we'll go to problem 2. It's a little spice here. Problem 2, though, and I have the paper here, and I'll read it. Given triangle ABC with the vertices mentioned, and the equation of the perpendicular bisector of segment AB to B. So we know segment AB's perpendicular bisector's equation. That equation is 3y is equal to minus 5x minus 13. And that's the information that we've been given, and we're to find the coordinates of the circumcenter of that triangle. So essentially, we want to be thinking about the midpoints of the sides of the triangle. We know that that line has equation 3y equals negative 5x minus 13. If we think about the slope of this line, it indeed is that negative, and everything is kind of confirming itself. So we either want to find the equation of the perpendicular bisector of segment AC or the equation of the perpendicular bisector of segment BC. From inspection, we are starting to see something interesting, but I think that this is how you would attack the problem. So you would just choose another segment on which to focus. Let's focus on segment BC. Segment BC's slope would be equal to 0 minus minus 5, which is 5, divided by minus 6 minus minus 3, which is minus 3. So that slope there is minus 5/3. So the slope of the perpendicular is positive 3/5. Now I just need to find the midpoint of that segment BC. The midpoint of the segment BC, negative 6 plus negative 3 is negative 9 divided by 2, and 0 plus negative 5, that's negative 5 divided by 2. So I just want to work with this equation. Y plus 5/2 is equal to 3/5 times x plus 9/2. Now, if we clean that up a bit, I guess I'll jump over here, we clean that up a bit, I could multiply this entire equation by 10, the least common multiple of both 2 and 5. So I have that 10y plus 25 is equal to, and then 10 divided by 5 is 2, 2 times 3 is 6, so I have 6 times the quantity x plus 9/2. We're a little scared by this fraction, but guess what? When we distribute our 6, the 2 will divide out there. So I have 10y is equal to, okay, well, let's just say 10y plus 25 is equal to 6x plus 6 divided by 2 is 3, 3 times 9 is 27. So this equation here is 10y equals 6x plus 2. I'm thinking I'm going to be solving this system. So why don't we, I look here and I can see everything's divisible by 2, so I'm going to clean it up even more. 5y equals 3x plus 1. So those are the two equations. 3y equals minus 5x minus 13. So we have 3y equals minus 5x minus 13. And we have 10y equals 6x plus 2. So we'll go back here. 10y equals 6x plus 2. I'll probably just multiply this by a 6 and this by a 5. So I get 18y equals minus 30x minus 6 times 3, 18, carry 1, 78. And I get here a whopping 50. Y is equal to 30x plus 10. Interesting. That's 68y is equal to, and that's minus 68. So y is equal to minus 1. If y equals minus 1, then minus 3 equals minus 5x minus 13. I take any of these equations and just plug it in. So that's giving me 5x is equal to this negative 10. So x is equal to negative 2. So I have a negative 2, 1 as the circumcenter of this triangle. Negative 1. Wow. Negative 2, negative 1. Really need to pay attention there. Now let's look at the geometric implications of this. Negative 2, negative 1. Does a circumcenter always lie on the side of a triangle? Well, not always, but we have a very special case. The special case we have is a right triangle. And we should have identified that by finding, we know that this AB's, the segment AB's slope is negative 5/3, and segment, segment AB's slope would actually be a positive 3/5, and segment BC's slope we found was negative 5/3. Those are opposite reciprocals of one another, therefore we have a right triangle. When we have a right triangle, and you're not guaranteed you have a right triangle, the nice and interesting thing is that circumcenter is on the midpoint of the hypotenuse of that right triangle. Look at that beautiful circle. That's what you're finding. You're finding the center of the circle that will go through all 3 vertices. Well, that was a little complicated. Now we'll go to our third example. And our third example is asking you to find the orthocenter of this triangle. And you're only given the vertices. You're not given anything else. So you're going to have to grind out 2 equations of the altitudes of this triangle, and you can do it. The altitude from point B, because we have an obtuse angle here, is actually outside the triangle. Interesting, and we can still deal with that. So if we were to do that, we would want to find the slope of segment DC, take its opposite reciprocal, and then from this point, and given that opposite reciprocal slope, we would come up with an equation of a line, and that line would actually be the equation of the altitude of an altitude of the triangle. So if we look at DC's slope, I could take negative 1 minus minus 5, which is negative 1 minus minus 5 is a positive 4, and then minus 5 minus minus 3, minus 5 divided by minus 5 minus minus 3 is a negative 2. So that slope there is negative 2. And we can see that confirmed here. So the slope of the perpendicular to DC is the opposite reciprocal. So that's 1/2. So I have my slope and I have my point, negative 3, 3. So I come up with an equation of a line. So I have this y minus 3 is equal to 1/2 times x plus 3. I'm going to multiply through by 2, so I get 2y minus 6 equals x plus 3, and that's 2y is equal to x plus 9. So we have one equation of the altitude. Let's go for another. And if you want to take a look at what we just did, we found the equation of this line right here. This line's slope is 1/2, and it does go through point B. The next one, I can pick any. I think most of us would pick this segment BD. Segment BD's slope, it's a vertical line. So the vertical line's slope is undefined. Therefore, the perpendicular's slope would be equal to 0. So, if that's the case, I know that this point here, -5, -1, and my slope of 0, -5, -1, and my slope of 0, my y would always just equal -1. Remember talking about that many times. If we have a horizontal line, your equation would be y equals some real number. A vertical line, x equals some real number. So I have this nice, neat equation, y equals -1. Now, if I have a system of equations and one of the equations is very simple, I'm going to use that. So I can take -2 is equal to x plus 9. Therefore, x is equal to -11. So -11, -1 would be the point of concurrency of the altitudes of that triangle. Here, here, and here. Notice those three altitudes intersect at the point -11, -1. Once again,